Let's take a look at the last concept in Unit 12. This is section 12.4. I can construct and interpret two-way frequency tables. So let's go ahead and fill those words in with two-way and frequency tables right there. And as a warm-up, I hope are familiar with this word, the word frequency. What does the word frequency mean? Frequency means how often something happens. So when we talk about its frequency, we're talking about how often it occurs. How often something happens. Okay, we've been graphing data on a scatter plot to see if there is a linear correlation. That's what we've been dealing with lately. There is, however, some data that doesn't really lend itself to making a graph, but we can make a chart. And the nice thing about charts is they help us organize the data and potentially see patterns. So sometimes the data we gather can be described in two ways. When this is the case, we can make what's called a two-way frequency table. So take a look at the following example. 100 students were going on a field trip. 45 of them were girls. The students could choose between the Clark Planetarium and the Capitol Theater. 60 students chose to go to the planetarium, 35 of which are boys. Make a two-way frequency table to display the data. Now, if you'll take a look at this right here, this is a two-way frequency table. And the reason it's called a two-way frequency table is because every one of these boxes right here can be described in more than one way. So the box right here represents girls that went to the planetarium. The box right here is boys that went to the planetarium. The box right here that's not filled in is girls that went to the theater, and so forth. This two-way frequency table contains all the same information as the paragraph up above, but now it's easier to see patterns and fill in missing information. We are missing some information about this table. We're missing some data about the girls at the planetarium, how many people went to the theater altogether, and that sort of thing. So we're going to go ahead and fill this information in, and then we'll answer the questions down below. So we want to take a look at this, and I'd like you to notice something. Notice that each row and each column has its own total. So we've got a total for this row. It's got its own total. So take a look here. We can use that idea to figure this out. Well, if we've got a number of girls and a number of boys and the total is 60, if 35 of them were boys, we can do 60 minus 35 and we get 25 girls. So there were 25 girls that went to the planetarium. Now take a look again. If there were girls that went to the planetarium and girls that went to the theater and girls for a total right here, if 25 went to the planetarium and in total there were 45 girls, that means 20 of them must have gone to the theater. Take a look at this bottom row. 45 girls, blank boys, 100 altogether. So this is going to be 55 boys. And then we've got some blanks right here that we can now fill in. So this is kind of like a puzzle. We go and use the pieces of information that we have, find little pieces like this right here. The first thing we found was the 25. That allowed us to find the 20. Same type of thing here. And now we're going to go through and say, well, look, if these are all the boys, there's 55 altogether. 35 boys went to the planetarium. That means 20 must have gone to the theater. So the last one here, let's figure it out this way. 60 for the total number of went to the planetarium. We don't know how many went to the theater, and then 100 altogether. So let's do a little subtraction problem. 100 minus 60 would be 40, and we can double check it this way. 20 plus 20 is 40. So notice that the last row and the last column should have the same total. So taking a look here, 60 plus 40 is 100, and 45 plus 55 is also 100. So we've got all the missing information in the two-way frequency table. Now let's take a look at the questions and see what we've got here. It says, was the planetarium or the theater more popular? So let's take a look here. Here's the planetarium, and here's the theater. So what we really want to look at is we just want to look at the total. It doesn't matter whether they're boys or girls. We just want to know which one was more popular. The planetarium had 100 kids that went to that, and the theater only had 40. So the planetarium was more popular. It says, what can you say about the students who went to the planetarium versus those that went to the theater? So let's take a look at the planetarium. And what we notice is that out of the total number of students that went, 60, 35 of them were boys, 25 of them were girls. So for the planetarium, there were more boys. Now, from the original information, we may not have been able to figure that out just by looking at the paragraph, but once we organize it in this two-way frequency table, this chart like this, then it's pretty easy to see. Let's take a look at the theater. So the theater, again, we're just looking right here. We're not ignoring the total and the planetarium. We're just looking right here. 40 total, 20 girls and 20 boys, equal numbers of both. So equal numbers of boys and girls. All right, let's take a look at down below here. Sometimes we'll be given partially completed table and asked to fill in the rest of the table, kind of like we were up above. We were given a partially completed table or just barely enough information to figure that out. Other times we may be asked to find the relative frequency. Relative frequency is another name for the percent. Relative frequency is another name for the percent. We'll only find relative frequency using the total for the entire table. So a good way to describe this is to say the whole table relative frequency or the table relative frequency. This is not the best way to find patterns in two-way tables. This is just kind of an introduction to how we can use percentages to kind of look at the information in a slightly different way. It is going to give us some basic insights on how we can use these. You're going to learn better ways to use relative frequency in two-way tables in the future. For right now, we're going to do the problems below and we're going to round to the nearest tenth. So as we take a look at problem number 3, and this is just like the one on your assignment, you'll notice that we have two frequency tables. This one has a number, so this is just the frequency, how often this occurs, and over here we've got a percent. So to find the relative frequencies, all we're going to do is we're going to take each one of the numbers and we're going to divide by the table total. So take a look over here. We've got some missing information. So for the time being, we're going to ignore this blank spot over here, and we're going to come back here and we're going to say, look, I've got male and females, and this is what they were doing at the park. They were either jogging, flying kites, picnicking, and then we've got a total for what the males were doing, a total for what the females were doing, and then kind of a table total altogether. So anytime we're only missing one box in a row or column, we can find that. So we could total these up and we could find this guy right here. So if we add those two together, that's 13 plus 10, that's going to be 23. We've got one missing box right here, so we can add those together, so that's going to be 20. We've got one missing box, so we can add those together, that's going to be 5. One missing box right here. Now we couldn't use this row to figure it out because we've got two missing boxes, but notice that we've got that missing there. So this is going to have to be 15. Now there are two ways to get this. We could either do 50 minus 23, which would be 27. But the cool thing about a two-way frequency table is there's usually two ways that we can check and make sure that we got the right answer. So let's take a quick look at this. The 27 we got by doing 50 minus 23. But we can also go through here and say, well, that's the total for females. We got these other numbers right here. Let's make sure that they add up. So there are 11 females that were jogging, 1 that was flying a kite, and 15 that were picnicking. So 11 plus 1 is 12. 12 plus 15 is 27. So these are the right numbers. That's how we make a frequency table. Now, a relative frequency table, what we're going to do is we're going to take each one of these numbers and we're going to divide it by the table total. So this is the table total that we were talking about up here. So I'm going to write some work over here. I'm going to put the 9 right there and we're going to divide by 50. And over here this is going to be 4 divided by 50, this is going to be 10 divided by 50, and this is going to be 23 divided by 50. Now I'm just going to do that row right here. So I'm going to pull up the calculator and we're going to take a look because this actually works out pretty nicely. So I'm going to grab the calculator and we are going to type in, we're going to do 9 divided by 50. Whoops, 9 divided by 50, and we hit enter. We get 0.18. Now remember, that is the decimal number that represents the percent. So we're going to move it over 2 places. So we're going to get 18%. So I'm going to write 18%. The next one is going to be 4 divided by 50. So 4 divided by 50. Okay, so we get 0.08. Next one, I'm going to do 10 divided by 50. And then I'm going to do 23 divided by 50, and I'm hoping you notice a pattern here. So this is 8%. This next one was 20%, and just to make sure, if we bring up the calculator, remember that 0.2, we move the decimal over 2 places, so we fill in that missing space with a 0. So this is 20%. The next one was 23 over 50, and we got 0.46, so that's going to be 46%. Now on this particular problem, you'll notice something pretty cool about this. The number here is 9, the percent is 18. The number here is 4, the percent is 8. The number here is 10, the percent is 20. And the number here is 23, the percent is 46. Because this is 50, we'd basically double each one of these numbers to make it out of 100%. Remember, means 100. So let's just take each one of these numbers and double them. This is going to be 22%. This is going to be 2%, 30%. This is 54%. Let's see, 40% right here, 10% right here. Double 25, we get 50%, and then double 50, we get 100%. Now here's the interesting thing about this. Both the row and the column will still total up. So if we add 18% plus 22%, we get 40%. If we do 18 plus 8, that's 26%, and 26 plus 20 is 46%. And take a look at this last column. 46 plus 54 is 100%. 40 plus 10 is 50, plus another 50. So it still totals up. All right. Now, this is just coming up with the relative frequency, or the frequency table, and then coming up with the relative frequency table. The percents here, just the raw numbers over here. Sometimes we're going to be asked to complete a table and then answer some questions about the data. So make some interpretations here. So let's take a look. Again, from your assignment, 8th grade students were asked whether they did homework after school. Complete the two-way frequency tables below, then create a relative frequency table, round to the nearest tenth. So again, we're going to go to the nearest tenth, and I think some interesting things happen right here. So let's take a look at what we can fill in. We really can't fill this one in at all. We could fill in this one over here using the 170 and the 350. Same thing for the male and female. So we've got actually 4 boxes we could fill in. We could fill in these 4, but we can't fill this one in the middle because we wouldn't have enough information for that yet. But let's see what we've got here. So if we do 80 and 200, 200 minus 80, this would be 120. Let's see, 350 minus 170 would be 180. Again, you can grab your calculator anytime you need to. And then here, 170 minus 80, this would be 90. 180 minus 120 would be 60. And if we add these together here, those will add up to be 150. And let's just double check. Does 200 plus 150, does it equal 350? And it does. So we've got this one taken care of. Check on that. Now we want to take each one of those and we want to turn them into a fraction. We want to turn it into a ratio that we can turn into a percent. So let's take a look here. We're going to take 80 and we're going to use this table total, and then we're going to do the 90 divided by the table total and so forth. So I'm going to write down some work over here. This is going to be 80 over 350. This is going to be 90 over 350, and this is going to be 170 over 350. So we're going to take each one of these numbers and divide it by 350. So this is 120 by 350. This is 60 by 350. And this is 180 by 350. And I'm going to change to a smaller marker here. So this is 200 by 350. 150 by 350, and 350 by 350. So I'm going to grab the calculator and I'm going to show you what happens here. Unlike the last problem, this turns out a little bit worse. So I'm going to turn this on, clear it off, and we're going to do 80 divided by 350. If we do 80 divided by 350, we get 0.22857. Well, if we're going to move the decimal over 2 places, and if we wanted to, we could make the calculator do that by timesing by 100. And there's our percent, 22% and a little bit more. So the question here is at 22.8 or 22.9? Well, that 5 is enough to bump it up to a 9. So this is 22.9%. So I'm going to write 22.9%. And you're going to see a couple interesting things happen here. So I'm going to go through and do a couple more here, and then I'll fill in the rest of the table. So we're going to do 90 divided by 350. Move the decimal over 2 places, so this is going to be 25.71, so that's not enough to bump it up to an 8, so that's going to be 25.7, so 25.7%. The next one is going to be 170 divided by 350, and we end up with, let's see, this is going to be, move it over 2 places, this is going to be 48.57. The 7's enough to bump that up, so this is going to be 48.6. So 48.6 0.6%. Now I'm going to go ahead and fill some of these in, and I'll bring you back in if I find anything interesting here. Sometimes the decimals work out as far as the tenths when we're changing to percents, and sometimes they don't. So I'm going to go ahead and work here. Okay, I've got this done, and I want to show you something. If we take a look at this row, we've got 22.9 and 25.7. If we add those together, the 9 and the 7, the 0.9 and the 0.7, they would make a 1.6. This ends with the right number. If you added those together, this is right. And then we've got 34.3 and 17.1. If you just take a look at the 0.3 and the 0.1, that would add up to be a 0.4 on the end there. That works out to be correct. And then if you add these together, we end up with 100%. So everything's good there. And this is what I was talking about when I mentioned that sometimes the decimals don't quite work out right because we're rounding on each one of those. So I want you to take a look here. This would be 0.9 plus 0.3. That would be 1.2. This should end in a 2. So let me show you what we've got here. If I were to take, I'll clear this off, 22.9, and we're going to add 34.3, we end up with 57.2. So that's really close, and here's the difference. The difference is the rounding that went on in each one of these numbers. So I'm going to do the 200 divided by 350 and show you that it is really close. It's almost enough to bump that up to 0.2. So this would be 57.114. That 4, if it were a 5, we could bump that up, but it's just really close there. So don't worry if these don't look like they add up. The same thing happens here, like these should add up to be a 0.8. They don't, but if you look from here to here, if we do the 57.1 and we add the 42.9, we do end up with 100. Now, even if these, say both of them were messed up and it didn't quite work out to add up to 100%, that's totally okay. That will happen sometimes, and it's basically just due to rounding, so keep that in mind. All right, once we have this information figured out, we've got it organized with the raw numbers in the frequency table, and we've got it organized with the relative frequencies in this percentage table here. It says what is the table relative frequency of females who do homework after school. So these are females who do homework after school, and it's the table relative frequency. So there were some that said yes and some that said no, so that would be 34.3%. It says, what is the table relative frequency of males who do not do homework after school? So males who do not do homework after school. So that's going to be this number right here. Again, this is why we call them two-way frequency tables, because there are two ways to describe these people. They're male and they said they didn't do homework after school. So that's going to be 25.7%. And now we're going to take a look at problem 8 on your assignment. So we're going to flip over to there. This is 12.4a. There are some problems where all you have to do is make a frequency table. Some you have to make a frequency table and a relative frequency table. So we're going to flip over here and we're going to take a look at number 8. Now, number 8 is kind of an interesting problem. It's a little on the crazy side. You went to a dance and helped clean up afterward. You collected soda cans, Coke and Sprite were served, from the tables and the recycling bins. Yes, you're an absolute complete nerd if you did that, I suppose. All right, it says complete the table and answer the questions. So this has the numbers there. We're just going to make a frequency table. So this is the information that was given. Again, it's not written up here, but it is given in the frequency table. So we can fill this out. So notice if we've got a total of 72 cans, 42 of them were in the recycle bin. That means 30 of them must have been left on a table. Gosh, that kind of tells us something right there. Now we know if there were a total of 30 that were left on a table and 14 of them were Sprite, 16 of them must have been Coke cans. Then we can kind of keep going here. We can take 51 and we can subtract 16, we get 35. And then this one right here, again, we'll do a little subtraction problem. 72 minus 51. This is going to be 21. And then the last thing to fill in, let's do this one. 14 plus what equals 21? Well, that would be 7. And always do a double check. 35 plus 7 is 42. So we've got the right numbers here. So our frequency table looks great. Now we're going to go through and complete our relative frequency table. I'm going to grab that small marker again. So our table total is going to be 72. So this is going to be 16 divided by 72, 14 divided by 72, 30 divided by 72, and so forth. I'm going to go ahead and fill those in. I filled each one of these boxes in with the correct proportion, with the correct ratio. Now I just need to type those into the calculator. So let me grab the calculator. I'm going to type in the first one, 16 divided by 72. And we'll hit enter and we get 22 point, moving it over, 22.22. So that's going to stay at 22.2%. So we'll write 22.2%, write that fairly large, make that look nice, and then I'm going to fill in the rest of them, and then we'll catch up with you later. I've got these all filled in now. Each one of them has been changed to a percent, so make sure that you know how to type those into the calculator, move the decimal over, and then round appropriately. I do want to show you really quickly that there is one here that does not match up. It doesn't look right. So this ends with a 0.2 and this ends with a 0.4. If we added those together, if we added these two percentages together, they should have a 0.6 at the end. So again, we run into that same type of rounding issue, but not to worry. These answers are totally fine. We're going to go with those. And then it says answer a couple questions. So what percent drank Coke and put them in a recycle bin? So Coke and a recycle bin. So this is this number right here that can be described two ways. Coke and recycle bin. So this is 48.6%. So we're going to do 48.6%. Drank Sprite and left it in the recycle bin. So Sprite and left it in the recycle bin. That's this one right here. So that's going to be 9.7%. What percent of the cans were Sprite? What percent of the cans were Sprite? So we're just looking at Sprite. So we're ignoring where they were found. We're just looking down here, and it looks like this is the percent right here, because Sprite coming all the way down here, Sprite that was left on a table, Sprite that was left in a recycle bin, that adds up to the 29.2%. So 29.2%. And then the last one, same question, it's just which ones, what percent were Coke. So that would be the rest of this 100% right here. If 29.2% of them were Sprite, then 70.8% of them must have been Coke. So 70.8% must have been Coke. Now that's enough to get you started and do pretty well on the assignment. Again, this is not the best way to look at percentages, but at least we've got an idea on two-way frequency tables that they can be turned into a relative frequency table, and then we can kind of talk about things in terms of percentages rather than just raw numbers. Sometimes percents make a little bit more sense. All right, good luck with the assignment.